Was everybody able to get through all the setup stuff? Okay, no problems? Cool. I definitely don't have time to do like a big extended setup uh, during the course of the tutorial today, so everybody who's set up already, I'm very happy for you. Oh, you didn't get the email, okay. So if you didn't get email with setup instructions and stuff, now's a great time to make a new PyCon friend with someone who did and is all set up. I also have a handout that has the setup instructions that I can pass now. Yeah. So the handout has setup instructions in the first couple pages, and then just some reference material. I don't know if you guys want to go ahead and pass that. And if we run out, I've got more. Take those and pass along. Yeah, I got a couple more. I also want to apologize to anybody who was trying to catch me during office hours yesterday. My baggage was all snafu'd and not a lot of fun.
Okay, yeah. So you basically could go here and he has the setup instructions. Yeah.
If you're looking for a spot, there's 2 or 3 chairs over here in the front corner. Extras? Awesome. Maybe extras. All right. So you get one. And we'll start these recirculating from the front again. All right. Everybody having a good PyCon so far? All right. Montreal's pretty awesome. I'm really happy to be here. I'll go ahead and get started with recording. Cool. Awesome. All right, welcome everybody. This is Shiny Let's Be Bad Guys. Today we're going to be exploiting and mitigating the top 10 web app vulnerabilities. My name is Mike Pirnat. Unfortunately, Dave Stanek couldn't be with us, so I get to carry on in his stead. And before we get going, I just have a few announcements I want to get through. So this session will run from 1:20 to 4:40 today. And as I understand it, the 20-minute break will be at 3:30. There are lots of awesome opportunities to volunteer here at PyCon. It's very low commitment. It's a lot of fun. It's a fantastic way to meet people. So I strongly encourage you to go do that. Swag bagging in particular is tomorrow from 3 to 7 p.m. in Exhibit Hall 220C. That's on the second floor of the conference center. Just do half an hour, 10, 20 bags. It's a lot of fun. You'll see what the amazing production is to put the swag bags together. And the registration desk welcomes volunteers at any time for 1 or 2 hours the most. Anything you need to, that you can do helps. And if you do it on Friday, you get a chance to meet everyone because the masses will descend and PyCon will be a really happening place. It's also very important that we get your feedback about the tutorials. You can go to the SurveyMonkey URL, PyCon 2014_tutorials, or if you like typing cryptic short URLs, you can use that shortened Google one. Please be honest. Let us know how we're doing, how we can improve, things you'd like to see from the process. And we look forward to getting that. I'll have these links up again at the end of the session as well. And one other thing, Heartbleed is terrible, and if your company isn't freaking out about it, they should freak out about it and go fix it. And we will probably cover that a little bit later on. It's a critical OpenSSL flaw that's hit yesterday, and many major sites are leaking user credentials, and could be pretty bad. So this is like national, do not go on the internet week, apparently. So anyway, Shiny, let's be bad guys. Why Shiny? Well, some of you may recognize that I still have feelings about Firefly. I'm sad that it's gone. Oh well. Anyway, and it gives us a chance to really kind of get in the mindset, though, of what we're going to be doing today and what we're going to talk about. One of the things that I get to do in my job at American Greetings is I get to deal with PCI and security issues and help educate people. And so hopefully we'll all get a chance to learn some good stuff today. So who out here has web applications in production? Who makes web apps? Awesome. All right, who has vulnerable web applications? Ah, you guys figured it out already. You saw right through me. Okay, so why does web application security matter? It seems like kind of a dumb thing, but you do have to justify it sometimes to your business owners. So it matters because you have users, and they trust you with their data. They trust you with a part of their lives. It's really important to protect that data. It's also your data as well as theirs. You don't want someone getting in and disclosing things that your company wouldn't like to be public, future plans, trade secrets, financial information. Heaven help you if you're storing credit cards. You don't want that getting out because it could cost you your business. Right? Your business's health and reputation depend in this age on being secure and being trustworthy and making sure that you're doing the right things. So how do we do that? What are some ways we can help? So the OWASP group is the Open Web Application Security Project. They're a nonprofit that's focused on improving software security, and they provide documentation and tools to help you learn about security and about protecting your applications. And periodically they release a thing called the Top 10. It's the Top 10 Web Application Vulnerabilities based on risk data from a bunch of firms and over 500,000 vulnerabilities that have been reported. And they select and prioritize them based on how prevalent they are, how easily they are to exploit, how easy you can detect them, and the impact that they might have on you. It was most recently updated in 2013. So today, what we're going to do is we're going to go through the top 10. We'll do a little bit of background about each kind of vulnerability. We're going to exploit it in a little toy application that hopefully people have gotten set up, ready to go. So it's a nice controlled environment. We're not going to go abuse the world and cause mayhem and get anybody arrested. We're going to talk about prevention and mitigation, how to avoid getting into trouble with it. And I'll provide some Django-specific advice where possible. And we'll also show some light examples where we have time. There is a lot of material, so I don't have in-depth examples on some of the stuff where there exists some other good tutorials and things that you can look at. So before we get going, a little disclaimer. What you do with the information you learn here today is your responsibility. Neither myself nor the PyCon organizers and staff are responsible if you decide you're going to go be a badass elite hacker and try to break into the NSA. So some of the things that we're going to talk about in here today can be criminal acts if you are running them against sites without permission. So grain of salt, this is about how do you make your own application stronger by getting inside the head of an attacker, learning to think like the bad guy is going to think about your site. And I also want to say a couple of words about Django. I'm not picking on Django in here at all. In fact, their security stance is really good. You get a lot of great stuff for free, out of the box. For many of these things, Django has to be specifically hobbled or mangled with in order to have these kind of vulnerabilities, which is really great. And they have a lot of other techniques to mitigate the things that you don't get out of the box. So we're really holding it up as a positive example, and I used Django for the toy application that we're going to bang on just because it was sort of an easy standard thing for people to get installed and get running. We're not going to get too into depth on everything with Django, so also please be sure to read the security in Django document that's on the Django docs website. And anybody who's not all set up, I would recommend you make a new PyCon friend and find somebody near you who is all set up. Show of hands, who needs a buddy or does not set up? Okay. So only a couple people, good. All right. Should we go ahead and get started then? All right, cool. So the number one is injection attacks. And what an injection attack is that's when an application sends some kind of untrusted data to an interpreter that then executes that or does something with it. So this can result in data loss and corruption, lack of accountability, and denial of access to your users. And in extreme forms can lead to a complete takeover of the host. So when you're taking an input from in your application, who can you trust? Who can you trust? Trust no one, that's right, the trick question. So your external users, can't trust them for sure, because the great public out there is full of bad people. Internal users, nope. Administrators as well. Even people who are well-meaning, like your internal users and administrators, can be tricked into using links and other mechanisms into exploiting their access, and then attackers can gain advantage on you that way. So some of the ways that injection attacks can come at you are in the get parameters that your application receives, in post data, in the path info in your URLs that are coming in, some HTTP headers like cookie and host that are supplied by the client, if you're not careful with those and sanitizing those can get you in trouble, and uploaded files. So some things that might happen. Somebody might create malicious SQL that does damage to your database or some other kind of bad query, maybe that abuses your Active Directory. They can access private files on your disk, and they can possibly even execute arbitrary code on your server. So a few real-world examples of these. Maybe everybody remembers the Sony PlayStation Network attacks a couple years ago. That was SQL injection. How many millions of records were compromised? Like 70 million user accounts? It's a lot. That's bad. Rails, last year, I think it was, Rails had a pretty bad vulnerability around January that allowed code injection. And then if you go to this ESPN link, this is kind of fun. So originally, ESPN had a really neat injection vulnerability where you could customize your own fantasy football entry. It was like a big fantasy football site. And my co-presenter, who's unfortunately not with us today, put together his own fantasy football biography because he's really into that. And so he could have his whole thing about how awesome he is. And because he used a site that had registered with a particular professional shortener, when he got the shortened URL, it looks like an official ESPN link. And so he could send that out and brag about what an awesome person he is on ESPN. So they've since fixed that, and it'll redirect you to an error page, but their error page will still take in text that will end up displayed in the page. And so they've got a nice little injection vulnerability there. So if anybody goes to that, it's not too bad. It just says hello PyCon. It's cute. Let's get to an example and start being bad people. So for our first example, we're going to talk about SQL injection. If you have not gotten the app started up, now's a great time to do that. So you run the Python manage.py run server to start up that Django app locally. And you want to go to localhost 8000 and into the first set of exercises. So in SQL injection, what the kind of problem is unescaped user input can cause the premature end of a SQL query. And that allows a malicious query to be executed. So in this case, in our example, we suspect that there's this kind of query that's live on the site that's going to select from users where username has that %s, and we're going to have some input injected into that. And let's see if I have it up there. Yes, good. So in this exercise, we're going to take 5-7 minutes and do a pretty simple SQL injection attack by trying to drop the user's table. Fans of XKCD might know how this one works. And if anybody has setup issues or questions about getting started, wave your hand at me and I'll be floating around. If you have any questions about anything in general as we go, wave me down and I'll come by while we're doing stuff. Sound good? Right. And let me get my timer going so I don't forget to restart this. And if at some point anybody needs me to flip back over to the other slide, I'd be glad to do that too. Just shout at me. We're all friends here because it's PyCon, so. Super quiet. Got it? Nice. Thanks. Yeah. And I will just say, because this is actually one thing that has tripped us up a couple times in the past when we've run it, the logic that's figuring out if you've got the vulnerability worked out is really, really, really naive. So don't try to do anything too fancy. It's just the most simple thing you can do to end the query and do your badness. Yeah. Yeah. Okay. Yep, absolutely. Yeah. Yeah, so we were talking about input fuzzing and trying lots of different things to see what the errors can tell you about what kind of query you might be running or what's happening under the hood. So it's, yeah, a lot of fun stuff you can do to cause trouble. Yes. Why is the comment at the end necessary? That's a very good question. So the comment at the end is necessary because there might be more of that original query that you're going to inject into the middle of. So you can just say, you know what? Forget the rest of this. We're going to finish your first query immediately We'll do my next query, and then the rest of this is just garbage. Ignore it. Yeah, no problem. That's a good question. All right, seems like a lot of people have this. How are people feeling? Should we keep moving? All right, wave your hand at me if I'm going too fast, over. Don't be shy. Okay. Cool, so maybe we're doing some stuff. Oh no, we gotta remember to end the query. And yes, there's our little Bobby tables. Let's show the solution. All right, so we can do this. So what we're gonna do is we're gonna use that single quote to finish the string that we're injecting into, and the semicolon to finish off that SQL statement. We'll drop table users, finish that SQL statement, and then use that comment to throw out the rest of the query. So when we do that, hooray, we've correctly created our successful bad query, and the users table is gone. Boom. We've now broken the hearts of school administrators everywhere. Oh, let's stop the timer. That was loud. All right. So another thing we can do with injection attacks is we can access private files on your disk. So maybe somebody wants your Etsy password or your Etsy shadow or something like that, or your Django settings. So this is where, if you've got something in your app that's accessing the file system, and you have unvalidated user input, an attacker can start walking your files and pulling out all kinds of interesting things. So in this case, in our next example or next exercise, just hit the next button on there and it'll take you into the file access one. We're going to steal Django settings and find out all kinds of things about the site so that we can leverage that for other attacks. Let's see if there's anything exciting about this. Yeah, so in this case, we're going to get settings.py. And again, if anybody's got questions or comments along the way, shout them out at me, wave your hands, get my attention. Uh-oh, there be hackers here. So you're on top of it already, you got it, I think. Sweet. Yeah. Yeah, so just as a general statement, this is all gonna be very simple forms of these attacks today. Really just trying to get, sort of that light bulb moment for everybody about how easy a lot of these things can be, and that sort of healthy respect for that. All right, how's everybody doing? See a lot of heads nodded. All right, hands up, anybody still working on this one? All right, cool. So everybody's got this figured out. We just want to start marching up the file system here with some dots and slashes that aren't going to be escaped. Oh no, there's our Django settings. So we can find out all kinds of things about maybe how do we get into the database? Where are we? Apparently I set the wrong time zone because I used the default when I created the project. Oops. Find out all kinds of things about what middleware you have enabled. Maybe you're running some vulnerable type thing that you want to exploit. Yeah, secret key. Is the secret in here? Oh yeah, look at that. So that might be important, right? If you're an attacker, things you might want to know about. All right. And so the third thing we're going to do with injection attacks is we're going to talk about arbitrary code execution. So this is where we've got some kind of unsafe input that's dynamically evaluated or executed. And in this example, we are going to, I think, write to the file system. Yeah, so we're going to write to the file system with some code that's going to be evaled or exec or something under the hood. And we're going to do some stuff to write a file. We want to write a file named pwned.txt. And we can use a Python one-liner to open and write that file. We'll give, we'll put 10 minutes on the clock and then see how that goes. And again, any questions at any time, please shout at me, wave at me. If I remember correctly, this is real similar to the Rails vulnerability, where they were taking in, I think it was untrusted YAML stuff, and it was their YAML was executing it while it was being parsed. Yeah. Yeah. So, so the comment from the audience was that there was a safe version of that YAML parsing that was like named _safe, and you were supposed to remember to use _safe, and most people didn't, apparently. So, which begs the question: why would you make safe not the default? And you, right? Slower maybe, but then you should make like parse faster or parse unsafely. Yeah. Yes. Okay. 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 Yeah. Okay. Um, hmm. Yeah. I'm sorry. Yeah. Yeah. So, okay, you'll raise your hand. Excellent. Thank you. I will look to you to be the hand raiser if people need some more time, because I definitely don't want to rush through stuff if people are not done yet or need a little more time. I don't want to be a jerk about it. So please don't be shy. We're all PyCon friends here. Yeah.
So is the idea to write Python code and
Yeah, so the idea is we're going to write some Python code that's going to be dynamically evaluated on the server side, and we're going to prepare that by getting it encoded so that it can go through and get unpacked by the server.
I
Yeah.
achieved it, but I'm not sure I understand how you would see that by looking at the source code
Okay.
of the page.
Um,
So I just
was there?
p64 encoded
Yeah.
eval open, but I'm not
Okay.
sure how by looking at the
Did
source
we have?
you would find that. Because I saw that.
Yeah.
So it's
Um, in the form, I believe there is a value that is.
I haven't seen any form with hidden values here.
Okay.
There's only this form.
Yeah.
So
So
maybe
was it?
I'm wondering if it's automatically generated by JavaScript. So even in
Yeah.
the live tree, there is no hidden input field.
Okay. Yeah. I will take that as a note to improve, to make it a little more obvious. Yeah.
do we need to know what that base 64 signature is?
So what you can do is you can write a Python one-liner and then base64 encode it, and then blast that in there
So
into the form.
so it's like something like this.
Yeah.
That would just be you wrap it around quote and you base64 b64 encode. Okay.
Yeah. So you can like fire up like an interactive Python session, import base64, and do the base64 encoding. This is probably like one of the more involved things that we're going to do today, and so
Yeah, I
like that
understand
kind of
that
two-layer
works,
thing.
but
Yeah.
I don't see how you would find that in an application.
Right. So
Yeah,
yeah.
I
So
understand it was
yeah.
the goal of the
Yeah. So in this
the
in this in this case, we're assuming that we've discovered it already, that there is some base64 thing there that we might be able to mess with. Um, yeah. So like so like base64 data is an interesting thing to find in people's source code in their web page, to see like, oh, what if you have all this base64 looking data in a form, what can I do with it? What is it actually, because base64 kind of jumps out at you after you've seen it a while. It looks
no,
it
I know. Yeah, I've already seen images inlined as base64,
right.
and you basically close the base64 and start some
Yeah.
JavaScript, and you can
Yeah.
debug JavaScript.
Yeah. What's that?
Base 64 is JavaScript.
Well, in this case, it's going to be Python that we're going to
Base64 is language agnostic library in different languages, but
Yep. Going okay or?
Base64
Yeah.
module reference would have been pretty.
Oh yes, yes, yeah, yeah. So it's in the standard library.
Yeah.
So, but yeah, I will note that for yeah.
Took your advice, turned off Wi-Fi. So.
Cool. Yeah, this is the only one that has like a live vulnerability on it. So
Got it. That's definitely fun to reverse engineer.
yes,
Solutions.
yeah. How's everybody doing up here? Doing okay? Yeah, the answer is in the JavaScript. So yeah, it's going to be easy to cheat. We're on the honor system here. Or you can use the solution button if you bang your head against it a couple times, and it'll help out. Yeah.
If I interpret this correctly, right, it says, you're clever and you noticed this basic
Yeah.
description, but I looked at that.
Yeah,
and
and
it's not-
yeah, and I apologize that text is a little confusing. So we're going to assume that there is a base64 encoded string that gave you a clue. And I will work on making that more obvious for a future iteration. Thanks for pointing that out. Okay, that was 10 minutes. How's everybody doing with that one? I see a thumbs up in the back. I see some thumbs up. Cool. Any objections to looking at the solution to this? Going once, going twice? Everybody good? Okay. So basically what we're going to do is, the way I solved this was importing base64 in an interactive Python session. I wrote a string of my one-liner. Let's open up a file in a writable mode, write something into it, and then wrap that in a base64.encode string, which will make some really nasty looking garbage here. And this double equals on the end is often a telltale sign of a base64 encoding. So then if we submit that, we just wrote a file to our disk and wrote it. Let's see. Yeah, server-side code just execute. Yeah.
I'm not entirely sure why they would be executing whatever is in the.
If something was, right? So, so I've seen applications where in order to save the database or make your database do less work, people will take a dictionary, serialize it off, throw it into a hidden form on a field on a page, and pass that value through like several steps of pages, so that you don't have to keep going back and hitting some resource like a database that's expensive to do. And it's very, very, very convenient and simple and easy if you took that and you just evaled it back into, maybe it's a dictionary or something in Python, and you just take that dictionary and eval it back. Well, that's going to cause that code to be executed as part of evaluating that back into an actual Python object, which is not good, because somebody can come along and do all kinds of things to you with that. So sometimes, if you're taking shortcuts to do things like that, it's maybe not the greatest idea. Right. So yeah. So on the server side, one thing that's really useful is the AST literal eval that will only make literal objects. It won't actually cause code to be executed. I'll talk about that a little bit. But yeah. So here's my file we just wrote. Let's look at it, just to prove that we did it while we were in here just a couple minutes ago. Yeah, so that's not good. We should not allow that kind of thing into our applications. So how do we prevent all this? Well, validate all the user input that you have, all of it. No excuses, validate all of it. You'll want to make sure that you sign cookies that you issue, and don't accept them if the signature is bogus or missing, right? So cookie gets sent in by the client, they could tamper with it as much as they want and give you some value. If your cookie has some format that they can figure out how to elevate their privileges or be another user, that's bad news. Cookie signing is pretty good when combined with SSL, although that assumes your SSL implementation is not broken. Thank you, Heartbleed. But you may also want to sign it with a user-specific key so that it's only good for user A and not ever good for user B or user C. And you guys may, or you all may know about Firesheep. That was kind of in the news maybe a couple of years ago. It was a Firefox plugin that makes it trivial to zerp up all of the cookies and logins and things going on, say if you're at Starbucks or Panera and people are logging onto Facebook and you'd like to maybe be them. You can just run this plugin and collect all their logins. So when you're talking to the database, you should use the ORM if you possibly can. And if you can't use the ORM, you should use your database API's bind variables so that that interface can do your scaping for you and you're not trying to format user data into those queries. Oop. And you don't want to use eval or exec. You should beware of using pickle because pickle has the same kind of vulnerabilities. There's even, a pickle cookie interface in the standard library that has huge warnings about don't ever use this no matter what you do, but yet it's still there. Okay, backward compatibility, I guess. User-supplied YAML is, like we were talking about, what got Rails into trouble. So that kind of stuff. So specifically to Django, what kind of advice can we give? You should make sure that the data types for your model are tight. And by that I mean, don't use string in your model when some more specific type of string might be more appropriate. Maybe there's a regular expression that defines your data better. Maybe there's a postal code or a phone number that defines your data better than just plain old string does. You should use forms, if you can, instead of model forms for stronger validation. And the reason for that is while model forms are really convenient, they're a really easy way to expose too much of your model and maybe provide access to things that you don't want to have your users be able to control or do things with. Don't be afraid to make new validators as needed for your application. So if you have some piece of data like, say, a phone number or a specific formatted token that you want to store, make a validator for that, not just, hey, whatever string you want, that's great. No, that's bad. And you also want to make sure that the URL regular expressions for your dynamic URLs are tight so that you don't allow garbage data, bad data, evil attacker data into your application without properly sanitizing it, right? So if you've got some dynamic URL, and we're actually going to see that in a little bit, if you've got some dynamic URL, a part of that URL could be acted upon or used against you. Use the ORM when you can, and when you can't, use extreme caution. Again, use bind variables. Django's ORM lets you do that pretty easily. And you should never ever use string concatenation or string formatting to build up a query or any other kind of interesting data that came from the client. So in particular with Django, without the ORM, you may want to use, so you can use the objects.raw to execute some raw SQL, and you'll want to pass this params dictionary so that it can fill those in, rather than trying to do string formatting and getting nailed with a SQL injection vulnerability. And if it's a more complicated kind of query, you'll need to go get a cursor and tell the cursor to go execute your query, and then it takes a list of the variables that you want to have filled in for you. And it'll take care of the scaping and make sure that that is not going to make you the next PlayStation Network. Okay, wow. So that's number one, that's injection. All right, should we talk about number two? Get your minds out of the gutter. Okay, broken authentication and session management is a flaw where an attacker uses leaks or flaws in your authentication or session management to impersonate a user. And the problem with this is that there are a lot of roll your own solutions out there that people just, it's easy to do it, so I'll just make my own. It takes 10 minutes, whatever, right? Well, these roll your own solutions really contribute to the difficulty of finding these flaws because you don't know that you necessarily even have it because you're using your custom home-baked thing and it's different from everybody else's custom home-baked thing. So again, we can use these kind of vulnerabilities to compromise user accounts, compromise administrative accounts, gain access to privileged functionality that we're not supposed to have access to. That's bad news. So because Django does things pretty well, we're, I think, not going to spend a whole lot of time doing any exercises against it. But you want to make sure your passwords are hashed properly or encrypted if you can't hash them, but please hash them because hashing is good. Don't let credentials be easily overwritten, so it shouldn't just be, I'm on the website and I want to reset my password, enter your email address, boom, password is reset. You know, having round trip is important. Possibly having security questions if you are more sensitive kind of an application. Don't put your session IDs in the URLs. Django doesn't do this at all, which is great. So you're protected from that with Django. But I'm sure you may have seen, you know, from back in the bad old days of the internets, as you'd walk around a site, you'd have this session, J session ID and a big long piece of garbage. Well, that's awesome. And now everybody who's in between you and there that sees your request can have your session ID. So that's not great. You should allow your session IDs to time out, and you should give users the ability to log out. And that sounds dumb, but there are places where you might build login or register, but without ever building a logout. So it's a good thing to remember to do. Yes? Right. So the question was about advice around using an external service like Kerberos or Active Directory or something like that to log out after some certain amount of time or to force a logout. Right. So in your case, it's a default 10 hours. So there are things you can do to make the session timeout earlier and make that, to invalidate the session at that point. So I think that's probably the best way to do it if you want to do that, right? Does that make sense? That's maybe not the greatest answer to the question, but yeah, right. So like log out on your site would just trigger the session invalidation, at which point your app doesn't know who you are anymore. So if you wanted to continue to access that functionality, you would have to re-auth. Although depends on how your integration is, right? Like are you talking about your application talks to the Kerberos server to get that, or is it a case of I already got this thing from somewhere else and now I'm going to use it? Okay. Okay, so something in the web stack itself for that application is doing it. Okay, so then I think that's valid, right? In the case of somebody goes to a service and gets a token that's good to use and that token is long-lived, there's not a lot you can do about it as long as that token still looks valid. And it's one reason long-lived tokens are dangerous. Make sense? Cool. And you should rotate session IDs after a successful login so that you don't reuse them for any purpose. And as long as you've fixed OpenSSL, TLS connections, anytime you're doing passwords, session IDs, user login credentials, you want that to be over an encrypted channel, not plain text. Again, heartbleed. So Django specifically, Django comes out of the box with Django contrib auth, which provides login, logout, registration, password recovery. It's really easy to customize. It's too big for us to dive into today in here, but there's plenty of great tutorials about it. If I can figure it out, anybody can do it. It's not too bad at all. It's very, very flexible with that. You should also consider middleware to do your session timeouts. I ran across this recently and was pretty impressed with it. So there's a Django session security middleware that provides a JavaScript and Ajax gateway to do your session timeouts. So it's pretty easy to set up. And it watches for clicks and scrolling activity and key press events in your app to keep the session alive. And if you hit some certain point where there hasn't been activity, it'll cause the session to log out on you. And we'll talk some more about transport layer security later on. All right, cool. Everybody happy about broken session management? Other than it sucks when your session management is broken? All right, cool. So let's get our hands dirty again. Cross-site scripting, number 3. So cross-site scripting, or XSS, is the most prevalent web application security flaw that's out there. This is where your app includes some kind of user-supplied data in content that gets sent to the browser to be interpreted without properly validating or sanitizing it first. So there's three kinds of XSS attacks. There's what's called stored, where the injected code is permanently stored in a database, a message forum, a comment, etc. So it's out there, it's lurking, it's just waiting for it to be surfaced and uncovered again. And anytime somebody surfaces that data back up to the browser, they're going to get hit with this attack. There's reflected cross-site scripting, where injected code is in the live request to the server, and it gets reflected back in an error message or a search result. So like that ESPN example that we saw is kind of like that, right? So you could imagine putting JavaScript in something like that that would cause it to do things to you. There's also DOM cross-site scripting. So this is where injected code in the browser DOM environment causes a script to run in an unexpected way. So maybe there's JavaScript on a page that's reading some value out of the URL, and you're going to subvert the logic that it's doing with that value or break what that logic is doing by having an unexpected value that it picks up. That one's kind of hard to wrap your mind around. It's very sort of inception-y, but can do bad things to you. So in general, don't do that if you can. So possible consequences of cross-site scripting. You can execute scripts in a victim's browser, obviously. You could use that to hijack their session, to deface a website, to insert some kind of hostile content that you don't want to have on you. You can use it to redirect users, and you can use it to possibly even hijack the browser and install all kinds of malware. That's no fun. So this is most often seen where user-created text is displayed to other users, so like comments and messages and things like that. In form inputs, where the value gets populated, the value attribute gets populated with user-supplied data. And in script tags, where user-supplied data might be placed into a variable in JavaScript so that JavaScript can then use that to do things on the page. And we actually don't see it maybe as much on form inputs anymore because many browsers are now blocking that or screening that because it's a pretty obvious thing. And interestingly, Internet Explorer was one of the first browsers to actually do that. When we would run this tutorial at work sometimes, we'd have people who would, all the people who were on Firefox and Chrome could totally do that exercise, and then somebody with IE says, well, hey, this doesn't work for me. It's not, like what I'm putting in isn't coming out in the page. So for once, Microsoft did a good thing first, and so hooray for them. Credit where it's due. So anyway, let's do an exercise. So we're going to look at using a dynamic URL to do cross-site scripting. So this is where a part of the URL path, that's the stuff in between all the fun slashes on the URL, that part of that URL isn't getting validated and is going to get included into the page. And that is insecure path matching. So what we're going to do here is we're going to manipulate the path to change the title of the page using JavaScript. And again, if anybody has questions, give me a shout, wave me down. I'm delighted to help out however I possibly can today. And I'll throw 7 minutes on the clock and we'll see if that's enough. I just want to make sure that we keep moving so we can get through everything today. Interesting. So you may need to encode that a little bit.
Yeah, but still
Yeah.
say that it's
Yeah.
correct.
Okay. All right. I will.
And
Yeah.
encoding
It's pretty trivial, I think, in terms of how it checks.
which library are ready to encode? URL encode is in which library?
Under the hood, the web app is Django.
I think you can import Django and
But I mean, it could, most of what we're doing is going to be in browser.
you can do JavaScript
Yeah.
URL encode.
Yeah. So using your favorite URL encoding stuff. Eric Meyer's got a really good one. I think there's a link in the handout that has that. Probably near the very end of the setup stuff. So, yeah, URL encoding and decoding. How's it going? Pacing better, people happier. You got me nervous now. Oh, good. Okay. Yeah, cool. Great. Awesome. Yeah. Yeah, so it's a pretty naive method of detecting stuff in the page, but
Because I've tried it both
yeah.
ways.
Have you tried encoding that for the URL? So if you take if you take this and get that URL encoded, that will probably have the desired result. And I will take that as a bug. Or please feel free to open me up a bug on GitHub, and that's probably I'm more likely to find it that way.
Okay.
I confess, probably at the end of the day, I am not going to remember a lot of tutorials. Tend to be a blur because they're like so long. So cool, thank you. How's everybody doing? You guys good? Awesome. Yeah. Yeah. Yep, I think you're on the right track. Now you may need a script tag, possibly. You can code that, so you can take that. Yeah, so I think you may need. Yeah, you may need a script tag around it.
Like in the source, it's already.
Oh, is it already in a
just
is it already in a script tag?
So
Okay.
it's just if I or
Oh,
put a
just
variable in
yeah.
the script.
Oh,
Okay.
so then I should be able to evaluate that directly.
Yeah.
Either that or your solution check has the literal same vulnerability.
I'm sorry.
Either that or your solution check has the same vulnerability.
Oh, that could be. Quite likely. Yeah, not intended to be 100% bulletproof.
So if it turned
Yeah.
out to be,
Yeah. Cool.
so there's a second vulnerability after the first one.
Oh, nice. Nice. All right. Okay. How's everybody doing? We ready to see the solution? All right. Okay. So here's our URL. We're going to close off that existing JavaScript variable with a double quote and a semicolon. And now we get an opportunity here to make a new piece of JavaScript. So document.title, please hack my users. And then we'll want to make sure that we reopen the string at the end so that we don't have a JavaScript error that throws the browser into a tizzy and then everything stops working because JavaScript. Yeah, yeah, that's another way to do it too. Yep. So here when we run that, oh no, we've changed the title of the document. Well, if we can change the title of the document, we can do a whole lot of other things that aren't so obvious, right? So we can use that to steal somebody's cookies, mess with whatever's in the page, all kinds of stuff. So for our next exercise, we're going to look at cross-site scripting in query string parameters. So in this case, the query string has unvalidated user input that comes in and gets included in the page. This is, I think, pretty much how like Dave found the ESPN thing was something in the query string. So in this case, what we're going to do is we're going to add an image element to the DOM. We'll point the source at a particular test image. And bonus points if you figure out how to do it without having it visible to the user. And in this case, if you can get an image into the DOM, what other stuff can you put into the DOM, right? You could put in scripts or other malicious payloads. Yeah. Oh, sure.
So I remove this and then.
So you need a forward slash. And then now we have a chance to start doing things to the JavaScript contents in that page. So yeah, so there's some piece of JavaScript that says variable equals open quote, whatever you came in from the query from the path, close quote, semicolon, and you get to play with the middle of that spot of the page, if that makes sense.
Okay.
Of the so what you'd want to do is just like a SQL injection kind of attack. We want to close the string that it's making. So there's some variable equals some string.
Okay.
So we close that off, terminate the statement, and we can now do something like this. Terminate the statement, and then now there's still an open quote that's left over, so we'll use that other open quote at the end to absorb it. And oh, I'm sad. Oh yes, these probably need to be. Yeah, these may need to be. Oh, it was path matching, so we want to do it in here. Yep. Yep. Yeah, close. Yeah, so that's like an opening double quote. Yep, and you just changed the title of your tab.
This is specific to the Django.
No, so this is a vulnerability that like anybody might have if you're doing something with a piece of that URL to put into a page. So I've seen apps that are like maybe you're walking through a catalog of products, and that's like a category that you're on, and that ends up getting included in the page in some way, either like as, hey, you searched for this, or now I'm going to show you things with this, this title or this category. And if you can manipulate that in ways that show up in the page, that can be dangerous. Cool, makes sense? Great. Yeah. Okay, yeah, that's fine. Yeah, that's okay, it's not a valid URL. Really what we're going to do is we're going to just be about populating something into the DOM that shouldn't be there. Because if you can do that, right, and it doesn't even have to be a real image, right? It could be anything. You could be populating a script into the DOM. You could be populating any kind of malicious object or malicious content in there.
So it's just a matter of having this JavaScript and escaping it and
Yep.
here?
Yep. Yep. Pretty much. Yeah. It's amazing how much of this is. Oh, it's just a matter of doing this relatively, right? It's not, rocket science or brain surgery or anything. It's surprisingly, frighteningly simple to do a lot of this stuff. You're welcome. Yes.
So where does the actual, I understand
Yeah.
this vulnerability, but how would this be used? Like someone sending a link or someone else?
Yes. Yeah. So you might someone might send you a link. Someone might have it posted, right? So maybe it's like in a forum and somebody's like trolling for like, hey, this is a popular site that has this vulnerability. Let's see what I can harvest. But you might present it in a way that is enticing, and you want to click on it because it's it's to a trusted site. Oh, I know that site. I go to Amazon or whatever.
I see. So basically your website ends up being used to install malware for you?
Yeah.
Okay.
Yeah, so you can leverage one person's weakness to cause damage to another person, or or one site's weakness to cause damage to other places, or infect their computers, do all kinds of stuff.
Okay.
That's pretty cool.
Yeah. So is that really common then?
Yes, yeah. Yeah, it's frightening. And that's a really terrifying thing, right? So this is a good message for everybody. It's terrifying that these are so simple and yet so prevalent. Like there's a reason these are like the number 3 thing on there. And actually cross-site scripting is like the most prevalent vulnerability that's out there because people just aren't aware to check, or the business doesn't want to give them time to do that because they don't know better or whatever. But yeah, it's really frightening. So after a couple hours in here, I think all of you will be in a place that puts you, frankly, in a much more marketable position, right? Because you're going to know about some of these things and care about them and understand the sort of things you need to do to protect against it. Right, so that's a good career advantage for you, as well as keeping the internet safe, because safe internet, good internet. Yeah, OpenSSL. Oh, heartbleed. Yes. In this case, this affects the site that you're trying to exploit. So someone could craft one of these links and put that in an email or a message forum or something in a way that's enticing to you. And I trust, I trust American Express, or I trust whatever big name thing. Sure, I'll click on that. And then you go there, and maybe nothing looks untoward at all, but you've just lost your session to somebody else, or somebody's gotten into your account or caused some other harm to happen. Yes? Yeah, so I think the hint here is that document.createElement is going to be your friend. So you're going to have to create an image element and do that, and then append that to the body of the page. Yeah, create element is probably like a good place to go to.
I first managed to hide it from the user
Nice.
putting it into the results element, which afterwards gets overridden,
Okay.
which was probably not quite what
No, probably not.
was the only one that was empty.
Right.
So easy to put stuff in there.
Right. Yeah. Almost there. All right.
Don't know how to. I don't know why I'm not escaping the string correctly. So I'm just putting this.
Okay.
And
What ends up coming out in your page markup? It looks like, so this is unexpected string. Do we have too many quotes going on, maybe?
So
Do you, because I
only one or two.
think you just need the one, but it looks like in your final one on that, like line 9 of your editor, it looks like you've got the %22, %22, so it looks like you've got 2 quotes going on there instead of the one. Yeah, try that. You're really close. Scroll to the right a little bit. Oh, okay. So you need the quote on the end. After your semicolon, then you need the quote so that it can absorb the rest of the string. Because you're still injecting into like the middle of a JavaScript string that's trying to be assigned. So you need that trailing quote on the end to make that, because otherwise JavaScript's going to see just an open quote by itself and a semicolon, and it's going to flip out like it did.
Append doesn't return.
All right, sound good? All right, I don't think I started the timer on this one, so someone make a rude gesture at me if you don't want to see the solution yet. No? Okay. All right. Everyone, should we see how this is done? All right, cool. So, we want to make sure we look at the HTML source and compare it to the query parameters so we can see what exactly is going in there. We want to make sure the JavaScript gets escaped correctly. And obviously, you've seen that create element and set attribute are your friends. Let's see the solution. Okay. So in this case, I whipped this up in interactive Python. So I grabbed URL-lib to do my encoding for me. And I made this big gross string. So I make a new image element. Var I is my new image element. I set its source to our test image that we want to use, and set its display to none so that it's not visible to the user, and append it to the body of the document. And then we just quote that to get a big gross link like this. And now there's an image in our page. It's hiding, so. All right, any questions about that? The one thing that seems to be worth noting is just about making sure that you get this last double quote so that that string that you're injecting into the middle of doesn't end up causing a JavaScript syntax error, right? Because just a quote by itself with a semicolon after it, JavaScript's going to see that and freak out. Okay, and the last one we were going to do is about cross-site scripting in form elements. And unfortunately, this is one where browsers are, well, maybe fortunately after all, this is a place where browsers these days are solving this problem for you and actively preventing things from being entered in that will prematurely finish a form element to allow you to put JavaScript in or whatnot. But the idea here again is prematurely finishing some piece of data on the page, in this case a form element, and allowing you to get JavaScript in there. So you might add an onClick or an onFocus that'll go trigger some other script to happen, or you might even break out of that element, inject a script tag into the page, and have it do things, and then you do something else to encode off or sort of consume the rest of the original piece of that form element. So this is a place where, I tried it on Safari this morning, and they've fixed it finally. Firefox is blocking it now. I certainly hope that Chrome does. I don't use Chrome because Chrome angers me. But Internet Explorer did it first. I was really blown away that Internet Explorer got this right before anybody else did, which is really kind of cool. So let's skip this exercise in the interest of time and everything, and let's ask ourselves a philosophical question. Can you trust your own database? How do people feel about that? Can you trust your own database? No, right? Because somebody might have managed to get something in there, slipped through, looked okay when it went in, but now that it's in your database, if you assume that that can just be regurgitated out to the web, it's bad news. So this is why you want to do things like escaping all your untrusted data based on the HTML context that that data is going to be placed into. If at all possible, use a whitelist to do your input validation. Not always possible. Names are terrible for that. I'd never whitelist people's names, because then you're in trouble. OWASP offers some auto sanitization libraries, like anti-SAMI, for doing validation, sanitization on rich content. Maybe not super awesome, useful for Python, but it's there, and it's something that you can look at and study and figure out ways to do similar things in Python. And it's a really good idea when you visit your in-laws or your parents to please update their browsers so that they can enjoy all these new features that are coming. So if somebody has really old Firefox or IE, they're going to be sad and have a bad day. Yeah, XP, right? XP just got end of life. We're all sad because ATMs are running XP and all kinds of stuff is running XP. Oh my God, right? It's terrible. So specifically with Django, be really careful when you mark variables as safe in your templates. So there's a safe filter, and there's also Django utils safe string that you can say, you know what? This thing is fine. You don't need to do any escaping when you put it into the page, when you're rendering that document. So normally Django likes to take any of your variable content and automatically escape it for you to prevent this kind of a thing. But there are places where you might have to create literal markup, and you want that literal markup to go into the page without being escaped. But you really have got to be careful with it, that you absolutely trust what that data is that's in there. When you're displaying a form in your template, don't just do stuff by hand, putting those values into the value attributes. Use the form.asp, asTable, or asUL functions when you're displaying it, so that Django can do that escaping for you as it's building the form. And you want to be careful when you're writing your own template tags. The Django utils HTML escape function is definitely your friend here, and it has some other some allies as well. It has escape.js and strip tags and remove tags. Escape will encode all of your ampersands, quotes, and angle brackets so that you don't get URL-y stuff and tag stuff in there. Escape.js will hex encode various values that are dangerous so that you can use those in JavaScript variables. Strip tags will remove all HTML tags from a block of text. And remove tags will allow you to remove specific tags, but allow others to pass. So if you want to allow, like bold or italic or something like that, you can do that in, your message or comment board that you're writing, but not allow, say, links or script tags. Any questions? Yeah. That's correct. Yeah, actually, I believe I actually disabled that under the hood in the view code and turned that off there. It may be in the view code, or it may be in the settings, and I forget. I apologize. It's been a while since I put this one together. But yeah, basically I deliberately crippled it so that because we're going to be doing a lot of these types of injection attacks, this application that we're playing with has been deliberately crippled in ways that allow us to do this and put unescaped data into the page. And hopefully, does that answer your question? Cool. Okay. So, number 4, this is a fun one. Insecure direct object references. And that doesn't mean these are object references that need to go see a psychiatrist and seek help for something. You know, these are places where we've got a reference to an internal implementation object without verifying that you're authorized to use it. And an attacker can change the URL or the get or post parameters or their cookies to go pick up, say, the ID of a different element. So a different user or a different blog post or a different account number, financial transaction, that kind of thing. So bad things can happen to you. You can compromise all the data that can be referenced by that vulnerable parameter. That's not good. And unless your namespace is sparse, so maybe you are randomly distributing your users across, you know, a billion or several tens of billions of values. If your data is sequential, you're in trouble, right? An attacker can just walk all the data of that type once they've got one number. So we're going to do just that, and this is a pretty simple exercise. So we're going to manipulate the parameters in a URL and access some data that doesn't belong to us and see what kind of trouble we can get into. So in this case, we have a user profile page, and you're logged on as user ID 1. Let's mosey for a moment or two here. It should be not too terribly involved after the last stuff. Yeah. And again, this is one of those things that it seems really, really, really like insultingly easy that this can happen this way, but it absolutely does happen in ways like this if people aren't thinking to put in the necessary access controls on those things. Yeah. Yep.
Admin have lower IDs than users because admin is created first.
Right.
And here the admin is the second.
Yeah. Okay. So the comment was that usually the admin IDs are created earlier than user IDs. Not necessarily always the case, right? You might have somebody who comes in, you know, due to employment and turnover and stuff. Somebody comes in later. But yeah. So, but the idea is, I think, still holds that by going and monkeying with that, you can be somebody else. Maybe you don't necessarily get an admin, but you get some other kind of privileged user, you know, forum moderator, maybe. You know, not that Flickr necessarily has this problem. I don't want to cast aspersions, but like you know, like an owner of a pool or a group of data that's like, you know, a user who's not necessarily an admin. But yeah, that's a good point. So maybe if you saw that and that was a really long number, you might start way down at the beginning. You might start with like a negative number, right? Maybe somebody thinks, oh, I'll be really clever and I'll hide my admin as user like -1 or something like that to fool those nasty hackers. All right, so has everybody got this? You want to see how it works? We're going to just go through. So, oh, I'm an admin, hooray. So some of the things we might do as an admin let's change the email so this guy's not going to know anything about password changes. Great, updated your profile. And you know what? I want a new password. Ha ha ha. Oh, you know what? Let's not let 1Password do that. No thanks, Safari. Okay. Well, so there's me using new tools. That's fun. Yeah, so what do you want to do to avoid this kind of thing? So you need access controls on any direct references to a resource that you want restricted. And you'll need to think about implementing per user or per session indirect object references. Now this is maybe a little more work than is necessary sometimes, but so an indirect object reference would be, let's say you have 10 values you might want to choose between. Rather than having the direct, like ID 1,000, ID 2,000, ID 3,000 of those things, you might instead use 1, 2, 3, 4, 5, and on the server side, map that 1, 2, 3, 4, or 5 back to what the actual real value was that you want to then be working with or submitting. That's kind of a pain, but is potentially a really good idea if the security of what you're doing, merits it. But really, having some kind of access controls around those references is important. So specifically in Django, you want to look into using the permissions architecture to lock down who has access to views, who's allowed to do certain things. And that's a little more complicated than we have time for today, but that's definitely worth looking into. And another cool thing you can do in Django is you can customize the query set that the ORM will use for looking up objects when ownership is involved. That's actually pretty straightforward. So Django lets you have custom managers for your model. So that manager is the thing that helps you get the data out through the ORM and kind of mediates that for you. So we might say, I want to be able to provide a way to get thingies out of the database that are particular to a user, only the thingies that this user owns. So in our models py, I've got a thingy manager, and it's going to have a for-user method. It's going to get me just the things for that user. And it will return self-get-query-set filtered by the user that we're passing in. So we can only get that user's things. And then in the thingy model, we need to make sure to use that manager. So we say objects is our thingy manager. So now, anytime we're doing queries against this model, we can do things like thingy objects for user and pass in the user that's associated with the current request. So now, this update view is only going to ever be able to update data that belongs to the user that's logged in. And you can do the same kind of thing with the other kinds of generic views as well, right? So the generic read views, create views, that sort of thing. Create's probably bad, but delete certainly would be a good one, right? You don't want to delete data that doesn't belong to you. Make sense? Any questions? No, right? So that's not limiting your sense of .all at this point. You can go and do that if you need to. But in this case, like, you might want to be able to still use the manager to be able to get at things that are not necessarily for that given user. Like maybe you've got some back-end process that needs to have that kind of access or so forth. But I find this is actually, it reads pretty well, and it's pretty easy to catch if you do. I don't know if people do code reviews and things like this. This is the kind of thing that could jump out really easily at a code review of like, hey, why aren't you using the right method for getting this user's data or doing something with that user's data? Yes, it makes it explicit and obvious. Explicit is better than implicit. Zen of Python applies to so many things. It's a good guide. I like it a lot. Anyway, Okay, everybody ready to move on? All right. So, security misconfiguration. So this is where your application may have insecure application settings, unpatched flaws, or unused pages, right? Maybe somebody made you do a page or some API endpoint for a project 3 years ago, and it's just still living out there. What I find is, developers, we're really good about creating things and updating things and deploying things, but we rarely get a good chance, and we're rarely paying attention well enough to remove things when they're not used anymore. So stuff can just linger for years. And then it might get found. So possible consequences here. So unauthorized access to system data, that's no good. Potentially, complete compromise of your system. Not good. Don't want that to happen. So we're actually going to do just a couple of demos rather than hardcore exercises here. How many people are like in the ops world as opposed to being straight up developers? So one, okay. A handful, okay, cool. So a lot of times I feel like the ops folks probably have more to worry about in the security misconfiguration world because there's a lot more to misconfigure, right? So there's your web servers and firewalls and load balancers and all that stuff that can go wrong too, as opposed to just, somebody doing bad app code. So let's take a look at a couple of pretty common security misconfigurations. One is the secret Django debug toolbar, right? So does everybody know about the Django debug toolbar? Okay, so there's a plugin for Django called the debug toolbar, and it's really great, and it shows you all kinds of data about the request that you made, what kind of request it was, what queries did it execute, how long did it take to render the page, and so forth. And it's really kind of fun, because Python's awesome and Django's awesome and everything, that you could dynamically add that into the page if you know some super secret thing to enable it. So in this case, if we set debug equals 1, we can allow debugging in production, except that I apparently broke this. Pretty sweet. Awesome. Good job, me. Apologize for that. So what would happen is you'd get all this interesting stuff along the side here that would tell you about things that you shouldn't know if you're not part of the organization. This worked like 2 weeks ago. I don't know what's going on with it. Oh, it works for you guys. Great. Sweet. It works for you, not for me. Wonderful. Murphy's Law continues to make an exciting week for me. But that's really not great in production, right? Because an attacker might come by and try. Hey, I see you're running Django. What can I do? Debug 1? Can I do something that gets me access to this? Maybe I've heard from somebody at a conference that some site did this, and I want to try it out. And now you can get information about, especially if you get like the query information, you can use that to turn around and then do SQL injection attacks, right? If you know, here's the query, here's what we executed, great. What can I put in to make it change? And you can even see that change because you'll see all the queries they're executing. So don't do that in production. You'd think it's convenient to help you diagnose a problem, but it's just going to eventually bite you. The other thing that is no good is having debug enabled in production. So, oh, great, we've got this exception. Well, we can see what's going on and what kind of Python we're using. We can see what's going on in the request. We can see all kinds of stuff. Now, the good news is that Django is very politely blanking out the password field for your database and is blanking out the secret key. This is, I think, a more recent development in the last year or two, but at some point that would have disclosed valuable things that you don't want the world to have. But again, even without those secret values, right, we can see what's all of your settings and what's in them and what middleware do you have, and do you have something that I could then use to escalate that into an additional attack or pivot on. So don't leave debug enabled in production. So to prevent security misconfigurations, it's important that you have a repeatable process for hardening your servers, hardening your applications. And you should have a process for keeping on top of any updates and patches to all the things that you're running. You need to know what do you have, and what's the version of it, and keep tabs of, oh, there's a security update for that, I should go install that. You need to think about having an architecture that provides secure separation between components, so that you've got things, you don't want things so closely bound that you get into one, you've blown through, and now all the crown jewels are your attackers. And it's a really good idea, and it's also mandatory as part of PCI if you're handling payment data, that you have periodic scans and audits to see what kind of security vulnerabilities you have on your applications. So, like we talked about with Django, don't run the debug mode in production. Please keep your secret key secret. Don't put it in your GitHub account and just upload your settings file. Don't just push all that up to GitHub and assume that the world is going to be nice to you. I think at one point there was even a pretty cool query you could run on GitHub that would just show you people's Django secrets in a nice, easy to find way. Oh, look at all these things I can play with. Great. You want to keep your Python code out of the web server's document root. That's probably obvious in 2014, but you don't want somebody to go, if you know, or you can guess the path to something, you don't want somebody to just punch that in and Apache cheerfully serve that up for you. Don't run admin on your public URL if you can help it. I believe this actually bit Twitter a couple of years ago, because they run their admin stuff, or ran their admin stuff on twitter.com, and had an admin account get compromised, and then badness ensued. So don't run admin publicly. If you do, maybe don't run it on /admin where it's really obvious. And if you can at all help it, please don't use the built-in Django admin for normal user administrative tasks. So things that a user would go to like a profile page to do, or if you're going to go edit a blog post or something, don't use the admin for that, because you want the admin for administrators. You don't want to have that out where everyday people are expected to use that as part of whatever they're doing. And it's time for sort of another interesting philosophical question. So we talked about, what can you see when you've got all those settings that get barfed out in that debug, right? So if you're exposing your errors in production, this can be a gateway to social engineering attacks, right? So in a big company, it's a lot easier to do a social engineering attack, because you might not know every other developer, like all the developers might not know each other. You might know, oh, I know these people in my team, but I don't know them. They're in another office in another state or another country even. And so if you have even the smallest amount of sort of inside information, you can sound really plausible with like, hey, I'm having a problem with this module in this app, and I got this stack trace, and here's what it looks like. What can you tell me to help me out, or who should I talk to get help with that? And then when you're on the receiving end of that, you were like, hey, somebody's coming for me to help. I want to be a helper. I want to be the hero who helps this person out, and then I can say like, look, I helped out all these people. Well, bummer, you just helped out the bad guy who's going to try to attack you. And you can keep leveraging that until you get to somebody or something that you really want to know. All right, so number 6, sensitive data exposure. This is where we are failing to properly protect credit cards, tax IDs, authentication credentials, sensitive data. And sensitive data deserves extra protection. So you want to make sure that you're encrypting it at rest or in transit. You're going to want to take special precautions when you're exchanging it with a browser. And so this is actually one that got rolled up. There were a couple of different OWASP vulnerabilities that got rolled up into this one when they redid it in 2013. And one of them is insecure cryptographic storage. This is where we're not encrypting the data that's worth encrypting. Or maybe we're using unsafe key generation and storage, or we're not rotating keys frequently. That's pretty common. People are like, hey, I've got awesome security keys. Great. Well, do they ever change? No. Well, then bummer. Eventually they'll get broken. You might use weak algorithms. You might have weak hashes or unsalted hashes. Adobe, LinkedIn, I think, right? So yeah, stupid Adobe, they got my account. I'm upset about that. Another one of these vulnerabilities that got rolled up in this is insufficient transport layer protection. So we might not be authenticating or encrypting or protecting the confidentiality and integrity of network traffic that's sensitive. So we might be using old SSL or broken SSL, thank you, Heartbleed. We might use expired or invalid certificates. Thank you, Heartbleed. We might use certificates incorrectly. And we've done something, we've set up our SSL wrong, and now we can have all that data compromised. So yeah, you don't want to lose all that data. It should have been encrypted, but you did something wrong. Now it's open for an attacker. And this can be stuff that's really, really sensitive. So login credentials, credit cards, personal data, health records, things that really matter to people and could have a real serious impact on their lives. So we don't want those users' data to be exposed. We don't want their accounts to be stolen. It's possible to compromise an administrative account, right? If you're able to observe those tokens or get it an admin's information. And a poor SSL setup can invite phishing and man-in-the-middle attacks. So, like if you have a self-signed certificate that's not really valid because you just made it up yourself and whatever, and your browser tells you, oh great, there's an error, this cert isn't valid, and you say, yeah, I know, this is my development server, that's fine, and you accept that. You train everybody who uses that, maybe it's a QA server, a staging server, you train everybody who uses that to keep just clicking OK and accepting the bad cert. And then what happens when they accept a bad one somewhere else? And then they become a victim, and their accounts can get compromised. So there's a couple of, several different ways of this kind of attack happening. So an attacker can monitor the network traffic of your users. That could be in a public place like Starbucks. That could be at your Wi-Fi of a favorite conference that you're at. I encourage everybody to use a VPN solution when you're at a conference or an airport or something. It might be in your back-end connections between servers, right? It might be between your app server and your database that somebody is able to monitor your traffic. It might be inside your network. You're not paranoid if they really are out to get you. There are plenty of examples of sites being hacked so that you can get shell access onto those machines and get inside the network and sniff all kinds of other stuff to see what you're able to get, right? So probably some of the NSA, SSL added and removed here, smiley face stuff kind of can play into that, right? So if you're just terminating the SSL at the outside and everything is in the clear inside your network, you might have a problem eventually. So you should encrypt sensitive data when it's at rest. So if you've got user credentials, if you've got payment information that you have to store, you should really be having somebody else do that if you aren't in the business of actually holding credit cards. Like, please don't do that. But you should encrypt it while it's sitting around doing nothing, just resting. You should encrypt your offsite backups. Manage the keys separately. So you don't want the keys for your encryption to go with that offsite backup. If you're going to back it up to some other site from some other vendor so that the vendor can't take that and go do bad things to you. You should use strong standard algorithms and strong keys. And you should hash passwords with a standard algorithm that's strong and use an appropriate salt, Adobe. Yes? Preferably somewhere that is also encrypted, like in a personal sense. like a keychain or a 1Password or something like that is valuable to keep that protected. If you're talking about like offsite backup stuff, probably you're looking at a different vendor. Yeah. So okay. Where's you? I understand your question now. So the question, yeah. No, sorry. The context for this question is about where do you put those keys so that your application server can get at them when it needs to use them? Because at some point you do have to have the key in clear text available to you as an application to do stuff with it, right? So I understand correctly now? Okay, cool. So some things you can do are to have that in a read-only, memory-only file system that only gets mounted by hand by a root user or a sysadmin user when the server is getting started up, so that you really have a controlled way to bring that in and get access to it. So I've seen that done in a couple of places. Yeah. Does that help a little bit? Okay, cool. And there's probably all kinds of insane hoops you can do, but eventually at some point, if someone's on your box, they're probably going to be, if they can read your code, they're going to figure out how to do that, and eventually you're going to have a bad day. But if someone's on your box anyway, you're having a bad day as it is, right? Does that answer your question? Hopefully adequately? Okay, cool. And we want to protect our passwords and keys from unauthorized access. So maybe, not everybody should even have read access to that read-only in-memory thing, right? Maybe not every database account should be able to actually get at the user's table or the password table or whatever, however you choose to store that. You want to require SSL for all your sensitive pages. Once that there's a fixed open SSL, thank you, Heartbleed. And you want to redirect all non-SSL requests to SSL, assuming you have a SSL that isn't broken. You want to set the secure flag on any cookies that are sensitive. So that flag means that your browser will only transmit that cookie value back to the server when there's an encrypted connection. You also want to use only strong SSL algorithms, obviously, and ensure that your certificates are valid, they're not expired, they're not revoked, and that they match your domain. Because again, if you train people to just blindly say, sure, that's a great cert, I'll totally accept that cert, eventually they're going to get opened up to man-in-the-middle attacks because of that acceptance of that this is okay to accept bad certs all the time. And if you at all can do it, having SSL and encryption inside your network on your back end is important as well. So in between your app server and your database server, between your front-end webs and other services that you might interact with inside your network. So specifically Django, you want to use Django contrib auth for proper password salting and hashing. They do a pretty good job of being serious about it and making sure that out of the box it's not going to be completely broken and damaged. You can require SSL using Apache or Nginx, which may be an easier course of action to you if you have either receptive ops people that want to work with you, or you are that ops person who has access to how your Apache or Nginx or whatever is configured. If you're not, or you don't have ops people that want to work with you on that, consider using SSL middleware for Django. There's a bunch of different solutions. All these links will be available in the slides when I post them, probably tonight or tomorrow morning. So don't worry about scrambling to get them written down. But there's a bunch of different Django middlewares that do things like requiring that if you access a particular view, it should be over SSL, or make your whole site SSL to be able to have all the URL generation generate you HTTPS links when it's appropriate, as opposed to HTTP links, and all that kind of thing. So when you do that, by the way, it just saves you that extra request and redirect loop. So keeps your site fast to have the right protocol on those links. In terms of secure cookies, in your settings pie, you can turn on the session cookie secure flag so that your Django session cookie will end up being having that secure flag set on it. And you can do the same for the CSRF cookie. that protects you from cross-site scripting. Now this means that your sessions, if you do this, won't work on plain old HTTP, and it means your forms can't be submitted on plain old HTTP. But it's perfect in a, well, was perfect in a pre-Heartbleed world if you could be 100% HTTPS, right? So there's this movement of Google and Facebook and all these other big sites to going all secure all the time. So this would be a no-brainer in a situation like that. Again, assuming an OpenSSL that isn't broken. Sound good? Cool. All right, we have a break coming up in about 20 minutes. We can get through a little bit more stuff first. Is that cool? Do you guys want to take a stretch now? Yeah, let's do one more section at least. Sound good? Cool. All right, so number 7 is missing function level access control. What does that mean? So this is where our application isn't protecting its functions properly, either due to misconfiguration or some developer who forgot to put the proper checks into the code, which is maybe more likely. So in these kind of attacks, an authorized user could change a URL or parameter to something that gives them access to a privileged function. And this could also mean that anonymous users could potentially access private functions that aren't protected. So you could doctor your cookies. That could be another way to do this, right? If you go in and tamper with the cookie and spoof that you're somebody else or that you're somebody with higher privileges. Like if you've got a user type encoded in your cookie and somebody figures out how to flip that bit, you could be in trouble. And it's important to remember that just because you don't publish a URL and tell people about that URL doesn't mean that people will not eventually find it through some means or another. So this can result in compromised user accounts, compromised administrative accounts, and again, more unauthorized use of privileged functionality. So we'll do an exercise, because I've been talking for too long probably. In our next exercise, we're going to manipulate a URL to access privileged functionality. And this is probably a lot simpler than you were expecting it to be. But that's all right. So we have this kind of fun flaw in our admin area. I have a happy little page, and it can be told an action that it wants to do. All right, thumbs up. People figured it out, right? It's sadly, depressingly simple to do. Oh, let's see what we can do with this admin action. Oh, God, I hope no bad guys ever get in here. So I don't see a lot of people doing this in Python right now, but I've certainly seen this kind of thing in older frameworks from other technology stacks, where you might have some Cold Fusion page or JSP thing or what have you that takes some action parameter that causes it to switch out what mode of functionality it's in. And apparently it was common practice at one point to be able to say, oh, I can do admin things on this page if I change out to this kind of action. Like, no, bad, don't do that. Right, so don't do that. And if you're going to do it, check to see that the person is who they're supposed to be. So you need, when you're architecting your application, to consider every single page, every URL, every endpoint that you can hit, and decide whether it should be public or private. And keep a list. That's probably a good idea, right? Documentation is a surprisingly good thing to have. If authentication is required for one of your pages or endpoints or what have you, make sure that there's checks in place that somebody's logged in, that somebody is an admin if it's an admin-only area, that somebody is a paid member if it's a paid-only kind of a feature. If additional authorization checks are required, make sure those checks are in place too. And a really good policy to follow is to deny all by default and explicitly grant access only to particular users or particular roles of user. And so again, this is a place where the Django permissions architecture can really help you lock down your views to make sure that you're only granting access to particular classes of user using the roles stuff. And again, don't use that built-in admin for day-to-day user activities or day-to-day administrative tasks. The built-in admin is really for like people who are running the site to make sure that it's still doing what it does. So our next section is probably going to be, this is our last like big, gnarlier, we're going to encode stuff and do things and do stuff that messes with the browser. Do you all want to take a break now? I see some kind of yawn. It's time to take a stretch break, get some water, hit the restroom. I think nominally we're supposed to be out from like 3:30 to 3:50, but since we're starting early, what do you want to say? 20, 25 minutes. Be back here like 3:40. Does that sound good? Awesome. Thank you.
I'm trying to figure out this code, but I don't quite get it.
Okay.
So I put this through the URL web, right? Encode and decode.
Yeah.
Encode and uncode, right? And I can see that it escapes the symbol.
Do we pretty much have everybody back? One. So one thing I need to get people's help with is apparently there is a sign-in sheet, and we want to just get names checked off if you're here, so that the folks down at registration can know like how many people showed up, of who said they were going to show up, and all that. So I don't know. Do people have writing utensils to check stuff off with? Is there a pen handy I can pass around with this? People have pens. Cool. So this will be coming around. Please find your name, check it off, and eventually get it back to me. Thank you. Yeah, I know. Like, ask a convention flow programmer. It's like, does anybody have a pen? What's a pen? All right. How were the snacks? Were the snacks good? I have no idea. I didn't get a chance to leave. Like, were there goodies out there? Are they delicious? Coffee? Okay. Cool. Well, coffee's better than no coffee, right? So, okay, cool. I wish I liked coffee. It's like one of my great failings. I don't like it. So caffeine and I don't get along, and like, so I get to be tired when everybody else is like, "Oh, I've got coffee. Everything is great." I hate you. All right, I've got 45 more seconds. Please enjoy a break for 45 more seconds. Yeah, there you go. Well, so my problem is, so like I don't pay the overpriced Starbucks coffee. I pay the overpriced Starbucks green tea lemonade mix. So there's a little bit of caffeine, but yeah, they got me anyway. Yeah, we've got a Starbucks in our corporate headquarters, and it's bad, right? Because you can just like walk down there and be like, "Hi, I want stuff. Give me stuff," and then go back to your job. And when you find like it's that second or third visit of the day, you're like, I need to stop. I work for American Greetings. So yeah, we've been doing Python on the web since 1996. It's pretty cool. Yeah. So before people had words like web application or web framework, So we have this thing that grew up out of the primordial ooze that was kind of like sort of a PHP-ish model of file-based traversal-defined code to execute, and that's eventually turned into something that actually resembles pylons quite a lot. All right, 3:40. All right, welcome back, everybody. Thanks for coming back, and I hope everybody's had a good time so far, learning a lot of stuff. Hope it's a good PyCon so far. So let's talk about another kind of vulnerability. So number 8 is cross-site request forgery. And this actually used to be much higher on the OWASP top 10, and it dropped way down to number 8 the last time it was revised, because so many frameworks are now out of the box protecting you from this. It's much less prevalent than it used to be. So that's a really reassuring sign that as a community, web development is getting better about at least one aspect of its security story. So CSRF, or cross-site request forgery, is where an attacker tricks a victim into submitting a forged HTTP request. And that attack succeeds if the user that gets hit with that request, or that does that request, is authorized or is authenticated to take whatever that action is. So this can come in several forms. You can hit an image tag that causes you to go do some request against a server. If you're logged in, you're in trouble. Cross-site scripting can be a vector for doing cross-site request forgery. You can have something from a different site that comes across and hits you with that. You can have a fake button. Maybe it's something that looks really enticing, like I want to download this cool app, or I want to see pictures of kittens because it's the internet and kittens are awesome. Yes, click, I want to see those kittens. But meanwhile, that's gone and CSRF'd you. It could be a phishing form. And there's some other techniques as well. So this can cause you to change any data that you're allowed to change. Maybe you're just changing your username or email or where your account beneficiary information goes. That would be bad. It can cause you to perform any function that you're authorized to use. So you could delete data, you could send emails, you could be relaying somebody's spam, you could be hitting somebody else with something that causes them to go download malware or own their computer. Then that impact is going to vary based on the victim's role. So an administrator might have even more access and more privilege that could be hit with. So there's some interesting possibilities. There's a good story here about a CSRF vulnerability that was reported to Facebook, and Facebook ended up paying this guy $5,000 for reporting it in a responsible way, and they fixed it pretty quickly, which is good. But it's serious, and people are taking it seriously, which is nice. Gmail, on the other hand, has a CSRF vulnerability that will log the user out. And it's pretty trivial to craft an exploit for it, and it's maybe only a nuisance level thing, but if you can make an image that you post on a forum or in email somewhere that's going to log you out of Gmail, that might be kind of annoying. Like, what if you've got your HTML mail turned on? Oh, cool, I got a new message. Let's see what this message is. Oh, now I'm logged out of Gmail. Great, now I can't use Gmail. Facebook actually had a thing kind of like this a few years ago, where you could post an image on someone's wall that would immediately log them out of Facebook. So anytime you logged into Facebook, you would see, you get things start to render, and boop, now you're gone. And then you're basically DOS'd from Facebook until that post fell off of your wall. So thankfully they fixed that a long time ago. But kind of examples of stuff you can do to people. So let's make a CSRF attack against ourselves. So we're going to have to do a little bit of mental inception brain stuff here, where we're going to pretend that one page of our toy site is really on a different domain from another page on our toy site. And we're going to have it attack itself a little bit. So we're going to craft an image that triggers some kind of functionality on the website. And you can also do this with an iframe. As long as a GET request works with it, you'll be able to do it. So let's go in here. So in this case, we have a website where an authenticated user that has payment on file information associated with them can easily send a gift card to a friend. Seems, innocent enough. We want to make sure that when they post the form, they're authenticated and they've got a payment on file. Okay, great. But if we weren't really careful and we didn't check that the post was actually a post, we could find another place that has an XSS vulnerability on the site. We could construct some URL and inject that malicious image that triggers a gift card purchase for you just by loading that image. So in this exercise, there's a form over here that we're going to use for reference. You'll want to take a look at the names of the elements. And we want to construct a URL that can inject that image link with some of these things in here. And there's a query string parameter that this page will take that will inject the image into this page. So we're going to use the form over here, read some stuff about it, cook up some badness. And what do you think? Like 8-10 minutes? Seem okay? All right. Well, I'll float around and check on people, and again, wave at me, shout at me, whatever, if you've got any questions about it. That's really bright. I know, my form has no validation for the attendance, I'm sorry. Oh, the irony. Yeah, I'm fascinated that in a conference full of programmers that this is how we check that people who said they were going to show up were going to show up. But now I'm going to get in trouble with the tutorial organizers for saying that on camera. Uh-oh. Hello. It's kind of a case of the cobbler's children having no shoes and the doctor's children being sick all the time, or grocer's children being hungry. I'll help with that. Here's the attendance thing. Thank you. Oh, how do you stop a cross-site request forgery? Yeah, so we're going to talk about that in a little bit. But yeah, the good news is Django out of the box protects you from this. And so for this example, I should really clarify. For this example, this is a place where we've deliberately crippled what Django gives you out of the box in order to be able to have these kind of vulnerabilities to play with. So I'm really glad that they protect you from this out of the box. It's nice that you don't even have to think about it. It's like it's an error to do this the wrong way. Well, it has actually dropped. So it used to be, I want to say it was like number 2 up until last year, and then it dropped all the way down to number 8. So this used to be much more prevalent, but many frameworks are now out of the box protecting you from it, which is really cool. So they've actually seen the incidence go so far down on it that it's actually, I find, very encouraging. It's still prevalent, but it's not nearly as prevalent as it used to be, like 2 years ago. Right. Yeah, or as things turn over from in-house things to services or tools that they've bought or whatever, right? Or they, people retool every, few years. As they get those new tools, the new tools are starting to protect them from these things. So there's it's actually really encouraging that there's this kind of turnaround in response on it. I would love for everything to fall off the top 10, and then I would love a new top 10, right? Like that'd be great. Yes.
So it's actually just more of a general question.
Yeah.
So how representative is the top 10 of like the vulnerabilities that are out there? Is it like the majority of vulnerabilities, or does like number 9, number 10, are those super rare? Or?
No, these are still the majority, so they're still fairly prevalent. So the data is from over 500,000 different reported vulnerabilities that then have been collated and categorized and so forth. So these are still like the most common things that are happening. But the good news is this has fallen very far down that list. So yeah, I would love for there to be huge turnover, and all of this is like gone. Like I would love to never have to talk about XSS again, right? Like that'd be great. Or injection, right? Like how awesome would it be if like just no one had injection attacks ever? It'd be good. I'll try not to block that as much. How's everybody doing with this one? This is kind of a little bit gnarlier than the last couple of little sort of pointy, clicky, handheldy ones. Anybody have questions or need a hand? Okay, cool. Everybody looks pretty busy. You want a few more minutes? Okay, cool. Anybody got it already? Ah, cool. Got it, or you have a question? You got it? Cool. All right. I'll add on a couple more minutes. And we'll go take a look at it in a little bit here. Got it? Awesome. All right. Everybody ready for the solution, or do you want like 2 more minutes with this one? 2 more minutes? Okay, cool. This is probably the last of the really gnarly things we're going to talk about today, so I think I'm good with that in terms of timing. Bring this with so I don't. you guys doing? Doing good? Yeah. All right, cool. Great. How's this part of the room feeling? Getting there? A little tricky? Okay. All right, you want to see it? All right, how about this part of the room? How you guys feeling? Y'all ready to see it? Okay, cool. All right, so this is a lot like the cross-site scripting with query parameters exercise that we did. Oh. All right, so I created a really gross-looking query string with interactive Python again. I grabbed URL lib and crafted this URL, so it's going to go against csurf gift card. We're going to pass in that evil email, an amount of $100, and then we're going to build JavaScript using that. So we're going to do that create element again to get us that image, set the source to our awesome URL that's going to get filled in, and set the display to none so we don't end up seeing it, and then we'll append it into the body. So then I quoted all of that. I formatted the URL into the source there and quoted the whole thing, and it gave us this really gross looking link. I don't know if you can see on the status bar. Let's just click it and see here. Oh, I've successfully patted my pockets on the backs of others. Hooray. So that ends up being this really, really gross escaped thing. So, okay, that's gift cards. That's maybe sort of a trivial, like, maybe that's not, you know, the thing that everybody's doing all the time, so it might be hard to do that, or you might not get a lot of hits. But what if this is like a banking site that somebody might be logged into? Like, you know, maybe pretty likely that somebody might have like a Bank of America or some kind of other account. And what if you had a vulnerability like that that says, I want to transfer funds for some large amount into some other account? And then you could just put that in an image, throw it on somebody's Facebook wall, and if they're logged in, you've just slurped money away from them, right? So a sort of similar exercise is we're going to create an innocuous looking form that posts to a vulnerable location. So this is the, like, hey, I want to see pictures of kittens because kittens are adorable. Unless you don't like kittens. Maybe you're a dog person. I'm not going to judge. Like, that's cool. Cute animals are cute regardless, right? So in this case, is an evil genius who wants to get money. We're actually going to do a small bit of jiggery-pokery hackering on the template for this page. That's in here in your favorite editor. And we're going to create a very simple form that's going to post data to that same gift card form. So maybe we've locked down that gift card form can't work with a get anymore, right? But it requires a post. Well, we can still make a thing that posts. It just doesn't have to look like a thing that is going to post. It doesn't have to look like a form to be a form. So we're basically going to do the same sort of thing. We're going to craft a form that does that. And we're going to be actually editing the template that drives this page. That makes sense? And there's actually a spot in the markup that it should lay out pretty clearly. Your form goes here. So that's a great place to go and add your form. Sound good? I'll throw throw 8 minutes on and see how we do in 8 minutes and add time if we need it. And again, at any time, questions, issues, concerns, like holler at me, wave me down. I think a few people were probably doing this one earlier, if I remember correctly. So. Yeah, that's not a bad idea. Well, I like them in sort of the order of it's wide open to gets and posts, and then somebody's said, oh well, I use a sophisticated routing mechanism, so I don't allow gets on this URL. Haha, take that, dirty hackers. But it's sort of, so the way it's arranged is for that sort of like escalation. But yeah, you can certainly consider that next time around. So thanks. Actually, frankly, feel free to send me any comments and stuff through GitHub, open issues on it or whatever. That may be the easiest way for me to find things later, because I'm probably not going to be awesome at remembering all of the things today. But yeah, so any feedback from in that sense is welcome. Or Twitter is good, or email is good also. So.
Well, I think I've seen slides around. Do you have the slides available so we could represent this to our teams?
Yes, so the slides will be available. This updated deck will be available probably by tomorrow morning. I intend to have fun socializing tonight. I hope everybody has fun socializing tonight because PyCon's a great place to do that. But probably by tomorrow morning at the latest, I'll have that up. Last year's version of the slides is available and is linked from the README and off of GitHub as well. It's, this has obviously had a few recent updates thanks to, Heartbleed, et cetera. So.
The day you find out you're not vulnerable just because you don't have heartbeat running.
Yeah.
So it's just like, okay.
Yeah.
So, happy accident.
Yeah. Yeah, I was really happy. Like my personal stuff is almost all static HTML that I generate, like my blog and stuff. So I yay, I don't care, or it's not SSL for anything because my hobby things are like little trivial rinky-dink toy apps that are fun. So like Python lorem ipsum generators and stuff like that. And
Generally, no tons of user data. Good.
right, exactly. Yeah, I as a for my hobby things, I really don't want user data. I don't want any. It's like too much of a pain for a hobby. Like, it has to be my job for me to really want to get into that. And
Did you
send
see
it.
the news anchor who bought their co-anchor Bitcoin certificate?
No.
The co-anchor, oh thanks, held it up, including the QR code. Somebody snapped it.
Oh, nice. Nice. So the comment was, for the record, there was a news story where an anchor bought a co-anchor of Bitcoin, and then they held it up and got the QR code, and somebody snapped it off the TV and stole it from them. That's pretty fantastic. It's an amazing world we live in, isn't it? The future. People can steal money from you on TV. Like, who saw that coming? What's that? Is Bitcoin money? Yeah. It depends on who you ask. It's property, right? Hey, but Bitcoin doesn't have a NASCAR car. The Dogecoin people, they're on the ball with that. Invading the public consciousness. Yeah. Oop, and I'm going to just drop my phone. That'll be pretty sweet. Yeah. Okay. Let's take a look at the. All right. So you're going to because we're pretending to be a third-party site that this is on. You'll want the full URL with the protocol and the local host and port number.
It doesn't accept if you just give your local IP, you actually have to say localhost.
Yeah. Good call. I'm sorry about that. Yeah, so we're specifically looking for localhost 8000. I'm lazy and I type localhost instead of 127.0.0.1. My bad habit, I'm sorry. What's that?
No relative URL?
No, because we're pretending we're actually attacking somebody else, right? So this is, imagine this is a thing that would show up on a message board or in an email or something that you would want to, oh, I want to click on that. Might not even be a message board, right? It could be somebody's fake site or lookalike site that's domain squatting, and maybe it's a typo site that's has all of your trade dress on it that looks like a legitimate thing. You're like, oh yeah, I totally want to do that. Now give me the amazing cashback bonus. I want all the bonuses. Yes, right? Yeah. Well, so a phishing email could direct you to one of these things that's then going to do that kind of attack against you. That if you happen to be logged in, bam, you're going to get hit. Yeah. Yes. Okay. Yeah, it's going to want. I think it's looking explicitly for localhost, like localhost 8000. Yeah. And then. Okay, so. Name, email. Type equals. I think we'll get there. Yeah, Chrome is delightfully correcting it for you, but or at least in the way that it's rendering it. Yeah, no, I really dislike when browsers think they're smarter than they should be. You got it? Yeah. All right. How's everybody feeling this side of the room? Oh, you got a question.
Why is this not working?
Okay.
Okay, so I go to my page. Okay. Oh,
Yeah, you did it. You got it.
it works.
Yay.
Oh, okay.
It didn't have the rubber duck present.
It didn't have the exact display value that I said.
Ah, okay.
Okay.
Stop. All right, this side of the room. How are you feeling? Feeling good? All right. We ready to look at the solution? Does everybody feel good about that, or want a couple more? Anybody want a couple more minutes? Not going to judge. What's that? You're okay. You're good. People around you good? Everybody good? All right. So let's take a look here. Vulnerable. Where are we? CServe. Third party. So basically, have a pretty simple form. It's going to post to localhost 8000 because that's the remote site that we're trying to exploit, and send that to the gift card form there. We have hidden inputs for our email and the amount of money that we want to make into a gift card. And we've concealed it with this wonderful, I want to view some photos button. Yay, kitten photos. And so I can do that. Congrats, I did it. I'm a bad person, and I just made money. Cool, any questions? All right. So, how do we prevent these kinds of things? A really good rule of thumb is to not do things on a get. Don't let get have side effects that especially like move money around or delete data or whatever. A Google spider would have a great day doing bad things to you if it starts hitting those gets. You can include a unique token in a hidden field. So this is often used in concert with a cookie, and this is how Django actually works. So there's a token that gets written into the form. It's also issued as a cookie to you, and when the post happens, if the value from the form doesn't match the value in the cookie, or the value in the cookie is not there, then it rejects the request. And you want to make sure to validate that token. Once you've got it, having it is only half the value. You actually do have to validate it once you get it to make sure that the request is from on your site. And you really, really, really want to avoid putting that token into a query string because it will get remembered by your browser. It can show up in browser histories. It can show up in people's logs. No good. So Django-specific advice, don't change the built-in settings because Django ships with CSRF protection on. There's a middleware that they have for this that's really great. And I've actually had to explicitly disable it in certain places to allow these things to happen. But don't turn it off, right? Like that's probably not a smart idea. Do use the CSRF middleware that they give you, and use the CSRF template tag in your forms. And like all the Django tutorials have that. It's a curly brace, CSRF underscore token, close curly brace. Be sure to include that or your forms won't work by default. You should be very, very careful about deactivating it when you need to. There's a decorator that you can apply to your views that's called CSRF exempt. That says, that's okay, this request can come from wherever and I will just cope with it. You need to really be conscientious about that. In particular, tools like TastyPie for easily creating APIs, and like RESTful APIs for your application. TastyPie puts the CSRF exempt decorator on all of its API call endpoints that it makes for you. So, yeah. Well, right. But think about if you are a mobile app that's just sending a post back to an API. Like maybe you didn't display a web page to get that token, but there are ways that you might want to consider working around that. I found this pretty interesting post about how to do CSRF protection in Django using TastyPie as well. So worth reading. And again, I'll have the slides up for you so you don't have to go memorize the URL or anything. But definitely worth reading and checking out. It's kind of a cool technique. Any questions about this? Yes? I don't know. That's interesting. I'll look into that. Right. Yeah. Well, so it's a similar sort of concept, right? That the session, like you've already been cookied with that session ID, and so providing that session ID back, but still you need to verify that you actually saw. I think you'd still want to verify that you actually saw the request come from something on your site, right? Because where's that session ID going to be? Is it going to be in the form? Okay. Yeah, but you still need something in the form of that page to know this post was the result of something that we actually showed to a user in a browser, and that this page view matched up with this token that we gave out, so that you know you're for sure coming on site. So I'd still use the CSRF protection anyway. I wouldn't turn it off unless I absolutely had to, and even then I'd be grumpy about it. Yeah. So the question was, can somebody just use an AJAX call to download a page and grab the token? Yeah, if you're paying attention and you are, watching for the set cookie headers and stuff, yeah, absolutely. Yeah, it's unfortunately, the stateless nature of the protocol means you could do stuff like that. Now, it depends on how long the token is good for, right? So you might not be able to use it for a long time, but you could probably still do that if you're a sophisticated person. Now, it may also be that by doing that, by having the protection there in general, you've made it enough of a nuisance for the bad guy that he's not going to want to bother with you because somebody else is vulnerable and he'd rather go deal with that, right? So it's not necessarily, with security things, a lot of times it's not necessarily about getting absolute complete perfection, because there's always going to be people who are, if they're motivated, they're going to figure out ways to be clever that you haven't thought of yet, or that outstrip what your preparations are. But you want to raise the barrier to entry so that it's difficult and frustrating for them, and they'll get discouraged and go somewhere else. That answer your question okay? Great. All right. Anything else about this? Going once, going twice. All right, let's talk about number 9. Using known vulnerable components. This sounds like a bad idea, right? So, yeah, libraries and frameworks and other modules that your application makes use of almost always run with full privilege on your systems. And it's really hard to stay up to date on everything. Do you know all the components you have and all their versions? And like, that's hard work. But for a bad guy, components that have known problems can be identified and easily exploited with automated tools, because machines are great at remembering all those things that are bad and being able to attack them. So an attacker can identify a weak component through scanning or some kind of manual analysis. A motivated person will then customize an exploit as they need to. And the good news on this, though, is that it is a more difficult exploit the deeper the flaw is in your app, right? So if it's up at the surface level and it's easy, your front-end website, let's say your front-end web server, like that's going to be a lot easier to exploit than something that's several layers down behind load balancers and firewalls and maybe internal firewalls and in the database. So it might be a while to get to one of those other things. But if somebody's in your network, then this is a cause for concern. So the full range of weaknesses and problems are possible. The impact could be really minimal, or it could result in complete host takeover, data compromise, fire from the skies, dogs and cats living together, mass hysteria. As we saw this week with Heartbleed. Again, critical flaw in OpenSSL. Yahoo was leaking user credentials. This is an apocalyptically bad kind of day. Not a lot of fun, and I don't envy anybody who had to deal with it. I fortunately only had to deal with Air Canada and trying to get my bag back. So I did not have to worry about Heartbleed. I just had to worry about having clothes for today. But yeah, it's really fascinating. I haven't spent a lot of time looking at it yet, but there's some very simple scripts, some of them even in Python that I've seen. Basically, like, Heartbleed exposes memory from affected servers, and you can read contents of memory out and get people's, all their private encryption keys and anything that's going on. It's really, really frightening. So hopefully everybody fixes their OpenSSL very quickly. So how do you prevent these kinds of things? Well, don't use any components you didn't write yourself, right? That's totally a realistic thing that you should do. Write everything yourself, even your crypto. No. Keep your components up to date. That's probably more realistic. So what does that mean? That means you need to know what you have and what version it is, and you need to keep an eye out for the security releases or security notices related to those components. And you just need a process to do that in a repeatable way, periodically. Just evaluate everything, see how you're doing, update anything that needs it. Specific to Django, when the Django project Twitter account says there is a new security release for Django, you should probably go upgrade, because they mean business. So they're good people to follow if you do Django development. So if there are no questions about that, this brings us to number 10, the end of the road for us here. Unvalidated redirects and forwards. So this is a place where, in redirection abuse, an attacker tricks you into visiting a URL that redirects or forwards the request without validating that it is going to a place that's okay. And users are prone to click on this because the link is to a site that they trust. You know, they might know, I love xyz.com. I'm going to click through that, no problem. And then it redirects them around, and before you know it, you possibly are at a lookalike site that is installing malware, is offering up phishing forms to entice you to interact with them and give up your data, or it's causing you to bypass access control and get redirected to someplace inside the application that you're not wanting to go to or that you shouldn't be going to. So we'll start first with a very simple exercise in external redirection. So we're going to craft a redirection URL to redirect to your favorite external website. And that looks like this. So the hint I'm going to give you is that you're going to want to take a look at the URL here for this page. And that's what you're going to want to mess with. Oh, look at that. It redirects to a URL. But just clicking on it doesn't do anything interesting. You don't see the effect in your browser because the redirect has already happened when you couldn't see it too fast. And it is 427. All right. Almost there. How's everybody feeling about this one? Should be pretty straightforward, no dark magic really required. This other room feeling good? You guys got it? Cool. Yeah. Yeah, this is the kind of thing where, like, if you're really banging your head against it, it's like you want to after all these other things that are more complicated. Like this is like shockingly painfully simple. So yeah, this is one where if you're trying too hard, then you're trying too hard, and just take a deep breath. All right, in the interest of getting us all out in a little bit here, you guys want to see? You all want to see the solution? Pretty straightforward. So I like example.com, so I'm going to copy this link. Boom. And what did I do before? Yeah, so here's my nice encoded example.com URL. The colon is 3A, and the slashes are the 2 Fs. And now I've redirected through my site out to example.com. So while this looks pretty innocuous and like who cares, you have a lot of possibilities of putting someone in a bad and dangerous part of the world using a trusted source to conceal that, that attack. So forwards are another really kind of similar thing, and we've actually seen something really similar to this earlier with the one of the earlier examples with the admin section with the action, the unvalidated action business. So in this case, we're going to manipulate a forward parameter to gain access to privileged functionality. Now, a forward is where it's sort of like a redirect, but you're doing it inside your application. So instead of going to an external site, you're being redirected to somewhere else in the app. And that is pretty straightforward, I think, as well. So just spend a minute with that. This is a place we're going to go to the super secret admin area again. Yep. Yeah, so a lot of times you might do forwards to say, great, I've handled the post. Now I want to show you something completely different, so I'm going to forward you through to like, yay, confirmation. If in any way that forward is variable or parameter, or you can parameterize it, then that can really screw you up and you can get into places you shouldn't be. So in this case, we're trying to forward to a happy thing. Well, it's not. Let's go to the admin interface. Oh no. And that is all of the exercise stuff. So how do we prevent these kinds of attacks? So if you can help it, don't use redirects or forwards. Obviously, that's not 100% realistic. So if at all possible, do not use user-supplied data to build what that redirect location is. You know, that should be something that comes out of the insides of your app that can be controlled by your development process and review processes. In the case of a forward, make sure that the supplied value, if you do have to supply one, is valid and is authorized for that user. So you shouldn't be able, Joe user with regular public person with no credentials, and you're not part of you're not part of the admin team. You shouldn't ever be in the admin area. You should never be forwarded to that at all. So Django has a Django utils HTTP is safe URL function to check redirect URLs. And it's used by Django contrib auth internally so that all of the things going in there will make sure that you're redirecting to your site and not redirecting you out to all kinds of horrible, nefarious places. You might want to consider wrapping is safe URL if you have to allow access to off-domain URLs. There might be companies that you're partnering with. It might be other slices of your site. Maybe your site is structured so you have different sites running on different domain names or subdomain names. The way is safe URL is implemented is it wants to check the redirect location against the actual host name that Django has been configured to use. So if you're configured to be www.example.com, it's only going to allow redirects to www.example.com if you're checking is safe URL through there. So you might want to wrap that up with some whitelisting stuff. So here's how you might check the redirect. So we're going to take a URL, www.example.com, foobar. We'll run it through the URL through is safe URL. We'll pass it the host that we want to allow. And if it's good, we'll redirect, and otherwise we'll act appropriately, do something useful. But you might want to whitelist that. So here's a real rinky-dink kind of way to do that. If you've got some list of hosts, we can walk through those hosts. We find one that's a hit, yay, we matched, we're good, we can allow this one. If not, we don't allow it. Yes, question?
How smart is that? Like if you're using www or the option not?
It is not that smart. That's partly why I suggest considering wrapping it. It's going to do exactly what you've passed it. So if you pass it www, then your link that you're validating had better have that www on it. Yeah, it's relatively naive, very just simple implementation. On the other hand, that's good because the behavior is easy to understand, right? So it's not going to surprise you. It's just, I'm going to check this, and if it matches this, then you're good. If it doesn't match it even in a little bit, then it's no good. Yes? Yes. Yeah, it's absolutely, absolutely. So the question was that we see sites where a login form has a next equals parameter that's used to control where you redirect to when you're done with that login action so that you don't interrupt the user flow. And this is absolutely a place that would be susceptible to this kind of attack. You know, a lot of places might have a page that is in the secure environment that will use like a meta refresh to redirect to a non-secure environment to get you around the warning that, oh, you're redirecting, like you did, maybe you finished a post in a secure environment and you need to redirect back to a non-secure URL when you're done. So you might have an interim page that does that along the way. That's a similar kind of thing. But yeah, so it's worthwhile to, you know, validate that that next is a thing that somebody should actually be going to, right? So a user logging in, their next parameter should not be into the admin land. It should probably not be off-site unless that's something that's allowable. Yeah, or some other form that's like delete my account. Exactly. Yep. Make sense? Cool. Yeah. Store the next in the session. Well, sure. As long as it depends, and it depends on where you validate. Like at some point, you're going to want to validate that next before you redirect to it. So like the Django contrib auth stuff uses this extensively, so that when you're telling Django's authentication mechanisms, excuse me, where to go when you're done signing in, or you're done registering, or you're done getting your, you know, requesting a password reset or something like that, that you're not going to get redirected out to somewhere else. You're going to stay on the site. Yeah. Yeah. So this is more about. Yes. Yes. Or so the question was, this is about being not being a vector for attacks on other people. Yeah. So absolutely, it's a lot about that. But if you have internal functionality as well, or internal admin areas, like it could be about that too, or some action like we were talking about, like you know, delete my account. You don't want to have like, hey, log in. You know, somebody could craft a URL that looks legitimate, that's to a legitimate site that you totally trust, but they've packed in this next value that's going to cause harm to you when you hit it, right? So it's about protecting the user too. Yeah.
OpenID is like, that's one of the big problems with OpenID.
Yeah.
It inherently redirects you to your OpenID login point, wherever that happens to be. You get users in the habit of going from like your app to Google.
Yep.
But if they rely on that redirect instead of opening a new tab and going to Google on their own, then
Yeah.
knows what they're actually signing into.
Yeah. So for the record, in case the camera didn't catch it, that was that OpenID has a huge problem with that, where people are dependent on going from your app over to Google or Twitter or somebody else to authenticate you and then redirect you back, and that can cause trouble when you assume that that's an okay thing all the time. Yeah, absolutely. Yeah. Yeah, so what you would end up doing is you could read that allowed hosts and pass it to something like this whitelist, or you could walk that allowed hosts and, you know, call is safe URL on all of them with the URL that you're going to redirect to. So yeah, they can go hand in hand there. Yep. All right. Yep. Yes, they are different. They are different functionality. Yeah. Yeah. So is safe URL is literally about saying, does this URL start with the host and protocol that the site is currently running on, but you have to explicitly feed it a value. So you have to go and say like, oh, I'm this site, read this, maybe you read it out of your configuration or something else, right? The allowed hosts would certainly help you build that whitelist potentially, right? But you may be also, like maybe there's other off-site things that you're partnered with that you want to whitelist also. All right, we're coming down to the very end here, so I want to get you out of here in a moment. So I want to revisit this question: who here has vulnerable apps? But you guys already ruined it for me earlier by raising your hands. So, but I want to leave you with a few parting thoughts. First and foremost, think like a bad guy. A lot of times we can get into trouble because we think, oh, we're just building our cool functionality and our users are going to love it and everything's going to be great, and we code for the happy path. We need to get away from that and think about, as you're building things, how would I attack it? How would I hurt this? What advantage can I gain against a user or against this business or against this website using what we've written? And really start, think about it all the time as, this is under attack and how would I attack this? Also, don't stop at 10. So these are the top 10 web app vulnerabilities, but that means there's more than 10. And this is a great starting place. This is a very great starting place, but there's more out there. So go forth and know about these, but know about more things too, and do more. You also have to be prepared for constant change in this space, especially as we saw this week with Heartbleed. Things can change all the time. New tools come out that the bad guys use. New techniques are discovered. You always have to be ready for updates or to pay attention to new methodologies or new types of attacks. But don't let yourself get too down about it. You really need to stay positive. Having a good, positive attitude that with a sane process and conscientious development, you can actually make a difference. That's really critical because you can have a huge difference by paying attention to these types of vulnerabilities and having processes around them, having code review to look for these things. Make this a part of what you do and a part of your culture, and you can really have a huge impact on making the web better. I mean, we saw that with cross-site request forgery, that it's dropped from the number 2 to the number 8. Let's drop it all the way off. Let's make it never happen again. So stay positive out there. It's pretty great. So recapping announcements, for tutorial feedback, here's the shortened URL. So we'd love to get your feedback. It's hugely important for the tutorial process and the planning process going forward. Again, there are many volunteer opportunities. The swag bagging is a lot more fun than it sounds. I did it for probably an hour last year on the huge assembly line and met a ton of people and had a great time doing it. So that's worth checking out. That's tomorrow from 3 to 7. Just drop by and help out. And the registration desk is always a good place to stop by and see if there are other volunteer opportunities. And please, 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 if you have something out there in production that has OpenSSL problems, go fix them, because Heartbleed makes me really sad, and I don't want to use the internet this week. So a few links that may be useful: OWASP, the OWASP top 10, the Django security document in docs.djangoproject.com. Really good reading, great explanations, good jumping off point to learn a whole lot more about how Django deals with these issues. And then the GitHub repo that you've already pulled down is up at mpirnat/letsbebadguys. I will have that updated by tomorrow morning with links to the new slides and all of that stuff. And if you didn't get enough of me droning on to you today, you can give me a shout. My blog is at mike.pirnat.com. It is woefully out of date. But I am on Twitter all the time, so you can tweet me at mpirnat, or you can email me, mpirnat@gmail.com, and I would love to talk with you more. So thank you, everybody, for coming. I hope you had a good time. I hope you learned a lot of stuff, and I hope you have an amazing PyCon. And it's 4:45. Everybody go have fun.